Alrighty-o! Here comes back to question 4. Alright, chapter 8, AE, question 4. Okay, question 4 states, on any day, the cost per item for a machine producing n items is given by delta C over delta n equal to 40 minus 2e to the power of 0.01 n, where n is an element of 0 to 100, and C is the cost in dollars. Alright, so let's look at a couple important things here. So we are given a rate function. Alright, it's the cost per item. Alright, so this is cost per item. Cost per item. Okay, so where n, now this is interesting, where they give us a domain for the n, where n is 0 to 200. So it could be 0 to 200, I suppose, yeah? And C is the cost in dollars. So, okay, the first question is, use the rate to find the cost of producing the 100th item. Now, the keyword here is the rate. So we have to use the rate, which is that function we got here, to find the cost of producing the 100th item. Not 100 items, but 100th item, you know, the trick on English words. Hate them. Okay, so we will have to, you know, just like the question suggests, that we have to use the rate function. All right, so delta dc over delta n will give us 40 minus 2e 0.01 n. And now we have to sub in, so we want to find the cost of producing the 100th item. So sub in n equal to 100. Find dc dn. Yep, so we have to sub the number in. So dc dn is equal to 40 minus 2e 0.01 multiplied by 100. Right, so dc over dn is equal to 40 minus 2 to the power, e to the power of. Now 0.01 times 100 is just 1. Alright, and 2 is, and therefore dc over dn is 40 minus 2e. Now e is Euler's number. It represents a radical number. Also irrational number, so you know, it's just decimal, keep going on, just like pi is. That I believe the value was 2.718, and you know, onward and onward. Now, therefore e is not an unknown, so please don't say, oh, I can't solve the question now because there's an unknown there. E is not an unknown. Okay, all right, so let me plug it in the calculator. Let's see what we get. 40 minus 2e. That give us 30. Will give us 34.5634. Now remember, this is the cost of producing the 100th item. So this is a cost. All right. So it's, you know, it doesn't make sense if you have so many decimals behind. So the cost of the 100th item would be, round up, I'll say approximately, you know, use approximate sign, curly, $34.56. Alright, so that's the proper answer. Remember, unit, unit is crucial. This is your unit, your dollar sign. Alright, let's go for the second one. Okay, express C as a function of n. Now, that would just mean to ask us to integrate the function. Because why? Why does that mean? Would that equal to integrate the function? Because once you integrate it, once you integrate the function, you get c on one side and n on one side. All right, so integrate dc equal to integrate 40 minus 2e to the power of 0.01 n dn delta n. Now, just for some of you who still who got this question, so where does 1 come from? All right. Well, the 1 is always there, and same as here. I just don't write them before. All right. So when you move the dn over to the other side, the 1 comes along as well. But we just, we never write them because there's no need to show the obvious. But when you only got the c alone itself, then there's a need to show the existence of the 1, and or else you got nothing to integrate with. So the 1 is always there. Okay, just to clear some of the thing that you might be thinking right now. So when you integrate a constant with respect to a variable, you get the constant and the variable. All right, we don't write the c one more, and so just leave it as a c. So here I would like to break into the 2 parts just like usual. It makes myself see it better. Oops, I'll just do that next part. Okay, 2e 0.01 and the delta n. Right, so we can solve this bit first. So integrating a constant with respect to a variable, we just get you a constant multiplied by the variable. All right, so minus, now there's a 2, the constant is here, so let's pull it out. Right. Okay. Now to integrate e to the e to the power of n, remember we can think about what we do when we differentiate something like that. So remember, when y equal to ekx, right? So when we differentiate that, which is dy dx, we do this to the other side. To integrate, so to differentiate, right? Yeah, you multiply by the k. So, well, I think just multiply by the k is not enough. I really think it's multiply by that, because you need to multiply by the derivative of the x as well. But because it's part of 1, but that doesn't mean that it's always part of 1, right? So. Excuse me, I get excited here. I get frustrated when the textbook rules is so it's so rigid, so it's not flexible enough. All right, but anyway, you know what I'm talking about. So to do the opposite, instead of multiplying k, which is derivative, to do the integration, we have to divide by the k, and the derivative of that. Okay, luckily, it's still fairly easy to do. So to integrate e, we write whatever is there, we divided by the k, which is the constant in front of the n, and the derivative of n, which is just 1. It's there. All right, don't ignore it. It's there, but just because it's 1. All right, and then we put the plus c at the end. All right, so we can expand the bracket. We get 40n minus 2e 0.01 to the power 0.01 all over 0.01 plus c. All right, to make it look tidier, we can multiply this. So 2 divided by 0.01 is same as 2 times 100, so it gets 200 e 0.01 n plus c. So now we got our cos equation. So expressing the cos c with a function of n, c on one side, n on one side. Now this cos, this c on the right hand side here is not the same c. All right, so this is the cos. All right, that is just a c constant c. So don't be a some people just say, these two c can cancel, or over there. Once you cancel it, what are you gonna solve for? Nothing. All right, so don't do that. Okay, so now we've got a function. We've got an incomplete equation because we've got an unknown in there, so we have to solve it. We want to find some sort of information to solve it, right? So we go. So for C, so we go back to the question and look at it. So so what we should be focusing on would be this bit. The n is an element or set of 0 and 200. So we have to make an assumption here, right? So assume Assume when n equal to 0, so we're not producing anything, no item is being produced, it will be logical to think that the cost will be 0 as well, right? Because we're not producing anything. So let's just use that assumption in there to figure out C. So once we apply it, it would be 0 equal to 40 times 0 minus 200 e 0.01 multiplied by 0 plus c. Now 0 is equal to 0 minus 200 e to the power of 0 plus c, right? Now I'm just going to take a 0 away. So negative, now e to the power of 0 is not 0. So remember, anything to the power of 0 will give you 1. So it's actually negative 200 times 1 plus c, which gives you negative 200 plus c. And when you move it to the other side, the c becomes 200. Right? So therefore, the actual cost equation is equal to 40n minus 200e 0.01n plus 200. Now, if you think about it, right, even though the assumption is true, if you're not producing anything, the cost of producing any, the cost of producing that item is nothing. There's no cost to produce the item. But why is there 200 there? Is because when you're running a factory, you have to pay for your workers, and just because you're having a bad day, no order comes in, doesn't mean you don't need to pay the rent. You can't tell your landlord and say, oh, because there's no order coming in today, therefore I have no money to pay the landlord. You'll be most likely to get kicked out, right? So I think that's, it's more realistic to have a constant here, because it will still cost you to keep the factory running, or the production line running, or the machine running. All right. So enough of the, this is applying the real life context, real life problems into mathematical, into math. Okay. So finally, we can work on C. What is the total cost of producing the first 100 items? Now we're looking at the total cost, which is C. All right. So for the first 100 items, so find C when n equal to 100. Now this time is not the C, the n. So remember, it's not the rate, it's not the cost per item, it's the total cost. So you have to use the total the cost function. So it's equal to 440 times 100. And there's a dot here. 100 minus 200 e 0.01 100 plus 200. Right, so that will give us 4,000 minus 200 e to the power of 1 plus 200. So that will give us 4,200 minus 200 e to the power of 1. All right, so the total cost would be 4,200 minus 200 multiplied by Euler's number will give us 3,656 point something. So remember, it's a dollar sign, so it's a dollar. So we have to use approximate dollar sign, the unit. 3,656 point, keep 2 decimal, because it's 2 decimal, the dollar. So that's the total cost, approximately 3,656.34 cents. $34, if you want to put it that way. All right, so let's see. The last question is, find the average cost of production for the first 100 item and the second 100 item. All right, the average cost of production is the same as the total amount of money spent on the production, which is 3,656.34 divided by how many products has been produced, which is 100. That will give us 36.56 approximately. So we change that. That will give us approximately $36.56 as the average cost for the first 100 items. All right. For the second 100, items, we first need to find out how much it costs. All right, what's the total cost for the second 100 item? All right, so let's find out using our cost equation. Now this time we have to put 200 instead of 100. Right, so our function is that. Okay, so it's be 40. 200 now, right? Minus 200e to the power 0.01 multiplied by 200 plus 200. All right, so let's find out the total cost. So that would be 8,000 minus t to the power of 2. Well, if times 100 give us 1, then times 200 give us 2, right? Yep. And then, oh, not anymore. So it would be 8,200 minus 200 e to the power of 2. All right, let's do that on calculator. 8,200 minus 200 multiplied by Euler's number to the square. That gives us 6,000 approximately. I keep forgetting this approximate. Approximately $619. All right, so that's the total cost to produce 200 items. But we don't want that. We want the total cost to produce the 100 item after the first 100 item, right? So we use this cost minus the total cost for the first 100 item, which is 3656.34. This is 3656.34. Just make sure it is right. Yep. All right, so that will give us the total cost to produce the second 100 item. 656.34, which will give us approximately 3,665.85. All right. Now, so to get the average of the second 100 items would be the same thing. So this is the total cost divided by the total amount of items produced on the second 100, which is still 100, right? So you get $30.66 now this time. So that's how much you'll probably get. So that's the average cost of the second 100 items. All right, so that's the answer for D, part 2. Whew, that was long. All right, so let's go to a commercial break as usual, and we will come back with question 5.